Welcome to stream number 36 in this series where I'm programming an NES game live on Twitch. I forgot to disable my phone so that it didn't make all sorts of crazy noises while I'm recording and streaming. So let's get that taken care of. So last time we left off, we had done some cleanup work where we were getting the game to properly bound the player ship within the confines of the actual playable field. We also got the status bar code working properly with the timing, and once we got that all good, then I think we kind of wrapped it up there. We had just done some basic cleanup there. I did later run this on an actual NES using my EverDrive and confirmed that that was working properly. So that's pretty cool because that means we've got all this stuff running pretty solid, and it's nice to see that working. So at this point we should try and see a couple of things. There are a number of things we could be taking on at this point. So we've got our map here. That's loading. Obviously the color palettes aren't loading properly right now. Should probably get to that at some point soon here. We had... Oh, that's interesting. I gotta turn off the rendering of the map. It looks like if you switch off of it, it's not happening. So let's fix that. So let's see. So that would be for that list item. That loads the map. So what we want to say is if it's not, probably want to say map buffer size is equal to 0. No. Is that right? Map buffer size is 0. Yeah. So I'll just kind of clear these out because we don't need it to draw the map. Alright, so if I choose the map again and switch to something else, it's not drawing good. Alright. We had made it so that you can click on a color and replace it in the meta tile. And then if you were to save that, I believe when I come back it should be correct. It is. Let me regenerate the meta tile again so it's got the right colors. Yeah, I'm not sure what I want to tackle today. I kind of want to... There are a few things we still have left to do for the maps, so we need to figure out how we're going to place things onto the map, like the spawn points for bad guys. So for the flybys are the only enemies we have currently, but I would imagine that we're going to have, well, not imagine, I know there are going to be more enemies than that. Part of the challenge there is like this map stuff is all placeholder still. I wonder if it's worth just getting the palette stuff going and then we can revisit the whole situation with the placing the enemies. Just because until we have some real art, like we know what the theme is, it's gonna kind of be hard to guess what we think is gonna be the right kind of behavior and the way to generate the code there. Probably also need to support multiple map handling. Right now it really only handles one map in the folder, which I mean works because we only have one map, but eventually there's going to be a handful of them You can add a note here. It's just another note. We have a handful of them at this point about handling map data. The idea is right now, because we just have the one map, there's no issue, but when we have multiple maps, we're going to have to, before we write out the map content, we're going to have to re-index those maps to handle meta tiles that we may have already loaded. And that's something that we haven't really done anything with right now. We haven't done any sort of deduplication or tile optimization or meta tile optimization, which we probably will want to do at some point, especially if we have larger levels, only because we're eventually going to run out of the char-rom space for our graphics. And even though we can do bank switching, it's still limited, and I don't remember what it's actually limited to. We didn't really. Let me go back and look at what the configuration is here. While I'm doing that, I want to mention that I know in previous streams I had talked about some shorter videos kind of summarizing some of these things and doing kind of a really condensed version of what we've covered in these live streams, and I'm still working on it. I was kind of fighting myself essentially in terms of how I wanted to put those videos together. So I originally wanted to do them way more sort of produced than they are right now, but found that it's just pretty time consuming to get the voiceover and everything correct. So I think I'm gonna kind of essentially I'm going to try and make it a little bit easier by doing the content of the video sort of almost as like a demo that I might do to someone, you know, watching on a screen share or something like that, and then add the content on top. Try to make it a little bit more clean and concise than these videos have been, these recordings. But yeah, we'll see how that goes. So right now it looks like we just have the one 8K char-rom bank, and we will need to, we can add additional ones if we need them. Right now I think we're good. We're not really using up that many tiles, but eventually we will want to do deduplication and then, you know, potentially spanning those ROMs. So let's see if we can get this whole palette situation figured out. So right now we do have configuration for the palettes that we're generating. So we have these palettes which are creating this palette table. And the reason we're doing that is so we can load the palette information based on the content that we're trying to load. It's basically indexed in accordance with the meta tile definition. So the gradient palette, which is meta tile 1, is going to be offset by 1 into this palettes table. And if you recall, we had done some testing in terms of the indexes that are generated. So it loads the index into X here and then uses palettes high and low to load the address and then calls the load pallet call to actually load that into memory. So and then that index comes from where? Where did was I manually generating that? I guess I probably, that's hard coded. Oh yeah, that's hard coded right now. So let's see. There's two parts to this. There's the part where we actually load the pallet. We've got that working essentially. What I guess I'm still not clear on how I want to handle is, so in the previous, one of the previous streams I talked about that we could have an area of memory where we're just constantly reloading the pallet information into the PPU, similar to what we're doing with the OEM data. We just load that up and then it gets copied when necessary. But that doesn't really answer the question of like when it's appropriate to change that memory to reflect the tiles that are loaded. Now, I think the first thing we probably want to do is, we'll start by the simplest case, which is we know we have less than the maximum number of 4 pallets for the name table. So what we can do is we can load the pallets. We can load the pallets straight up into memory when we load the level. But I think I want to have that get directed by the way that we write out the file in the asset tool, because I think ultimately the asset tool is going to be what's figuring out how we handle manipulating the pallets in the PPU. So, and I had even written these notes at one point in an earlier stream where I was saying the first thing we need to do is we need to look at what the content of the map is at the first screen, and then write out the indexes of the pallets that need to be loaded to start off. So let's do that. So it's going to be 4 bytes after this row count byte that we're writing. So the first thing we want to do, so we want to, we'll call this P because it's the pallet loop that we're doing here. We're going to say this is P is equal to the beginning of the first screen that we're loading, and P should be less than let's do it would be that. So let's do this. Map beginning. Right, so that's, so this is map beginning plus map width times 7 because it's 7 rows, and then plus P, and then we can change this to map beginning, and then I have to spell this right. And I know technically I don't need this because of order of operations, but it just makes me feel better to have it. All right, so we want to loop through that. And we want to, how do we want to do this? We want to basically say, okay, we want to find out which pallets we need and write them up to 4 pallets. And this is really not the right way to do it per se, because we might have more than 4 pallets here, but this is just sort of like we're just getting this kind of bootstrapped here. So, no, but that doesn't take into account the ones we've seen already. Let's see. How would we do that? Well, do a simple what? A simple pallet. Pallet. What do we want to call this? I don't even know what you would want to call it. It would be a lookup table, I guess, and we'd have, you know, there's going to be, right now at least, a maximum of 256 possible pallet values based on kind of the limitation that we would have for the number of pallets that we would support. Sorry, the number of metatiles we would support. Because there's only 1 byte per metatile, so we would only be able to support 256 metatiles. So, yeah, so this is unsigned. What we'll do is we'll say, okay, if pallet can, lookup table, and this would be map buffer p equals 0, then we're gonna, so basically I'm just making a simple array where they're all initialized to 0, and as we find them, as we find a new one, we're gonna write the pallet index into the map, and then we will increment the pallet count. This way we're not getting duplicate indexes, and we're not we should have the right offsets. Again, this is not probably the best way to do it, but it's simple and it'll work for what we're doing right now, where we're just trying to get the pallets loaded for the simplest case, which is that the map only uses the same 4 pallets for the entire thing, which for the beginning is fine. So let's do that. So let's write map, write map file, map buffer p, right? And so the pallet is offset by the same amount as the metatile right now, and we're writing 1 byte. I believe map buffer is just a char, so that's good. And then pallet count gets incremented. So let's do this. Let's run this, and we'll do the export and just make sure that we're seeing some sane values here. So pallet count is, that's interesting. So what was P's value? Oh, we only saw, so in the first screen, okay, yeah, that would make sense. So in the first screen, we only saw the first 3 pallets, which is not exactly what we want to do. So let's do this. Let's just start with the beginning of the map, like the actual literal, man, I just can't speak, the actual literal beginning of the map, and then we'll say we'll go until we get map, the end of the map, which is map width plus map times map height, right? Or is it? No, it's just map width times map height. So we'll go all the way to the end of the map. If pallet count hits 4, then we're done. Otherwise, we will have to write an additional pallet value because we only encounter 3 pallets. So if P doesn't equal 4, while P is less than 4, we'll do write map. Well, that's stupid. Write map file. Oh, that's not going to work. I need to know. No, we don't need to know that. I'm looking at the wrong variable. Sorry. Pallet count, it doesn't equal 4. Then we want to write. Just write 0. And it would be 4 minus pallet count. Let me think about that. So if we had no pallets for some reason, then we would get 4, and then if we had 1 pallet, then we would get 3. Yeah, that looks right, except this is not right. This should be 4 equals 0 because we want to write. Yeah, okay. I wanted to do this because instead of looping to write 1 byte at a time, we can just write up to the 4 bytes we would need to. All right, so let's try that again. So if we export this, we have our pallet lookup table. Let's see what's actually in it in terms of what we encountered. So we encountered 0, 1, 2, 3, and 4, which makes sense. So then we have pallet count of 4. Let's go back and rerun this and make sure we're not getting into that loop. We're not, or that if statement, I should say. Okay, we're not. So now we're writing those 4 bytes for the pallet into memory. The only thing about this for the filler tile doesn't actually count, right? The filler tile is always going to be the background color, so it doesn't need its own specialized palette. So what we can do is we can say pallet lookup table 0 is equal to 1 just to skip the filler tile. So export that, and then if we look at it, we should see 1, 2, 3. Okay, so there were only 3, and if we go to the map, there were only 3 meta tiles, so that makes sense. So if we finish exporting this, and then we go to Fred, and we look at the binary, we have the number of rows, and then we have the pallets that were encountered, except that they were not encountered in order. So the question is, well, that's okay as long as our attributes are written in the same way. Right, so originally I was going to try and keep it to the same order, but so that, you know, tile 1 is pallet number 1, and then tile 3 has pallet number 3. But what this is doing is saying, okay, the first pallet I encountered was 1, and then the next pallet I encountered was 3, and then the final pallet I encountered was 2, which is, I'm going to scroll all the way down here, and that's fine as long as the meta tile information that we're dealing with has the right attributes, right? It's going to have the right attribute loaded into the screen. So, and the attributes are where things kind of get a little nutty, because that's where we need to, that's where we have some of the challenges, because as we're loading in the tiles, we also have to load in the attributes. So the first thing, I guess or actually after we're done loading the first screen, we probably want to generate the buffer for the attributes. So at least that screen is right. So let's see, how would we do that? So we know the attributes look like this. We know that the attributes are 32 by 32, and we know that they're divided up into 4 16 by 16 regions, and so you have 2 bytes, is that right? No, 2 bits in the byte for a single byte that gives you the palette information for that region. So we strategically chose the 32 by 32 metatile size because it makes updating this easier. 1 metatile is equal to a single byte in attribute memory. And then let's go to NESDEP, because I remember there's some weirdness with the way that it's arranged. Attribute tables, and it's arranged where top left, top right, bottom left, bottom right. So it's this is bottom, that's bottom right. This is bottom left. This is top right. And that's top left. Now, the good thing for us is that for the most part, this shouldn't be that big a deal to do, because our metatiles will mostly fit into just a single byte. Now that's not true as we scroll, because if you remember, the screen is not exactly 8 metatiles high. So we're going to run into parts where we have to split this into 2 halves of 2 different palettes, but it's not as bad as if we had to do it with 16 by 16, where each one is a totally different one, potentially. So what we would need to do is go back to here and say, okay, so for attribute is less than, let's see, we want to start, well, we want to start at map beginning. And we want to go map beginning plus map width times 7, right? So we want to go right to the end. Attribute. All right, so that's going to loop us across this, and then what we need to do is write the bits for each of the metatiles. Now, like I said, the good thing is that our metatiles essentially are a 1-for-1 with the way the attribute table works. So the only thing we need to do, let me think about this. So when we're writing the palettes in metatile 1 We need to know the index in the pallet lookup table. So while pallet lookup table pallet index well, actually that's not it's not exactly how we want to do it. What we want to do is something like this, where we say final palette, or I'll call it map palette. And I get, you know, that this is again kind of messy, but we'll make it work. We'll clean it up. So map palette into palette count equals what is this? Map buffer p. So basically what we're doing is we're sort of doing the reverse, or we're storing off the result into this map palette buffer, where we say, okay, if you encounter this meta tile, the index at which you encounter it is the index for the palette. And that would be true of all of them except for tile 0, for meta tile 0. So what we'll do is say if map buffer adder equals 0, then we want to continue, because there's nothing to well, actually it's not, we still have to write something for the attribute, so, but it doesn't matter. So what we can do is we can say write map file we'll just have this I'm wondering if it makes more sense to do an attribute buffer, and then we can just write that whole buffer at once. It'll be technically faster than writing the single bytes out. So attribute result, and it's, what is it? I think it's 64. 1024 minus 960, right? Yeah, 64. So adder index. So adder index, adder result. Equals 0 plus adder index, continue. All right, so we've got that correct. And then what we're going to do is we're going to say, okay, if the right, it's palette index, no, it should be less than 4. So then we're going to say, okay, so if the meta tile isn't 0, then what we need to do is we need to we actually need to update this thing properly. So we'll say let's see, while palette lookup table doesn't equal map buffer adder and palette index is less than 4. We'll just do palette index. We'll increment that, right? And then whatever the value is, we need to, it's going to be 0 through 3. If it's 4, then something went wrong. Probably want to assert here. So, all right, so we're going to have the possibility of 0 through 3, and what we want to do is we essentially want to copy that bit pattern into the rest of into the attribute result value. So we would say this, I guess. We'd say pallet index shifted by 6, or pallet index shifted by 4, or pallet index shifted by 2, or pallet index. Right, so basically what we're doing is we're saying if the, let's say the pallet index is 2, right, the binary value for 2, we're saying, okay, take that value and shift it over by 6 bits, put it here, then shift it by 4 bits, put it here, shift it by 2 bits, put it here, and then we're kind of replicating it across, and that OR, that bitwise OR is just applying it to the final value we're getting here. So, and then once that's done, we need to write that value. This is going to be attribute result, size of attribute result. So basically we're writing out the first set of values for the attribute table. So this is going to break the game, but this will load the palette properly into the attribute table once we have that worked out. So let's export. And where are we here? So this is the map beginning. That's the first screen. That's fine. So that's going to export the first screen. Oops. So what's the problem? Index, is it because what's map? Map buffer attr. It's 2. Palette. Oh, because I'm using palette lookup, but that's not right. It should be map palette. Okay, so that was a silly mistake. And then, all right, so let's see how that works. Okay, so the attribute result, bring that into the viewer here. What we should see, if I can expand that out, it's going to be 64 bytes of memory with the content of essentially how the attributes should be laid out for this part of the map. Doesn't look right because let's see. Well, maybe it is right. Because it could be, right? Because 1, 2, 3, 4, 5, 6, 7. So that's the first part of the screen. All of that would be, well, we should be seeing a bit of stuff there for this tile being different. So let's see here. Do 7. It's still 0. All right, so let's look through this and see what I messed up. So we're going to start at the map beginning, which is the start of where the first full frame begins. These comments are no longer correct. Actually, we don't need to do this then. What we can do is we can say we're setting that there, and we just write map palette. Oops. This is what map file map palette for. So that wrote our 4 bytes correctly. All right, so, and then these. Right, so let's see. So we say we're going to start at map beginning, and we're going to go until we get to the map beginning plus the map width times 7, which is the full first screen. And we're going to say, okay, if the map buffer attribute is equal to, or the map buffer tile is equal to 0, then we just set this to 0 and continue. Otherwise, we say, okay, if the map palette value matches the attribute, or so, let's see. I think that might have been the problem. While the map palette index doesn't equal map buffer, so when they are equal, we should break out of that, and as long as palette index is less than 4. All right, maybe that was the problem. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. No, that doesn't look right. It still should be a problem with the way we're doing this bitwise stuff here. Let's see. So palette index is 0. Okay. Palette index is 2. So the attribute index, let's is 5. Attribute result is that. Let's drag this up into here. Right, C138, yep. So palette index shift by 6 or palette index shifted by 4. Okay. Oh. Well, no, it was incrementing it, so that looks right. So that's going to change that to AA, which if we look in the calculator at what that actually looks like, right, we see 10101010, which is fine because palette index is 2. That's exactly what we want. So next time around, change it to 0. Why didn't attribute... Oh. Damn it. I created attribute index, but then used attribute, and I don't need both. And I don't need that. Sorry, that was just from changing too much stuff around. This should be much better. All right. Is processor feature what? Why range check failure? Oh. Yeah. Okay, now I remember why I did that. Okay, sorry. Dumb mistake. So the reason I had created that attribute index variable was to iterate through attribute result, but I wasn't properly incrementing that every time, so that's why it was overwriting values and not generating the right result. So that was just got lost in what I was trying to explain, and obviously that didn't work. All right, let's see here. So it updated the value with A, and then the 0. Okay, that's looking better because it's actually getting some values that make sense. That looks to be right because we would see these diagonal tiles here. Everything else would be pallet 0. So that's okay. So that's 64. We write that out. Write out the rest of the map. All right. So let's see what happens. Sorry, I bumped the microphone. Let's see what happens when we bring this into the game. And obviously we have to fix the fact that we now have some additional information in the map binary. So let's pull all of this stuff over. Okay, and then in the assembly, we say load level. So what it needs to do first is it needs to... It stores the max rows. Don't really care about that right now. We increment the sprite mem. Then we want to load sprite mem y. This is pallet 0. And then to load the pallet, we have to we use param1, I believe, as the index. Load pallet. Header param1 has the address. Well, why would I do it that way? I mean, I know why I would do it that way, but I don't actually like that approach. Does this modify attr param? It doesn't, right? It modifies y. I think what we want to do is I want to load the base offset, and then in this case it's 4 for param1. Let's just make sure that that works for the title screen. Oh my gosh, what did you do? That's not the assembler. Syntax error 473. Load X 0. That's what I changed, right? Yeah, load X 0. We need to populate those parameters, and then this is 4, and then that should still work. But of course it didn't. What did I screw up? So the idea was I wanted to change it so that it's loading the base address of the pallet table and then offsetting by the appropriate number of bytes based on the index that's coming in param1, which is what I thought I had done originally. So load a 2002, load a param1, and then multiply by 4 to find the index that we need to find. Store a param1, increment param1, because we don't want to set the background color. Okay, so what did I mess up? Pallets high 0. Oh, should this be 5 because of the... No. Is this making any sort of difference? No. Let me go to my pallets here. 0, 1, 2. 0, 1, 2. Right? Well, not exactly. 0, 1, 2, 3, 4. So pallets 0 would give me the address for filler tile, and then pallets 1 would be for gradient, pallets 2 for blue tile, pallets 3 for green tile, pallets 4 for title screen palette, right? Or no? Add a param1. Is that just changing which, if I make this 8, what does this do? Messed up that. If we make this 12. This isn't what it's supposed to do at all. Or is this... I always... Still... Yeah, see, this is... The high byte is in +1. So that's okay. So pallets high X should have let me see here. My subroutines. I'm looking for a jump subroutine here in the load title screen. It's too early. That's the basic initialization here. That's controller code. Store A 10. Load A 0. All right, let me just do our usual little breakpoint here. Run load X0. So EC13. Saying, oops. Offset EC13. So EC93. Okay, that, I mean, that seems right, because we would write that into so EC93 got written into here, which should be the palette colors. Load A4, store it into the into param1, and then we're going to jump to the subroutine. Just going to push A, transfer Y to A, push A again, and then it's going to read from 2002 to get it ready for loading the palette. So we're going to load 4 into A, and then we're going to multiply it by 4 to get the offset, which is 16. Right, because it's palette 4, so yeah, that should be 16 bytes. And then we're going to store it into the parameter, and then we're going to increment 1 because we don't actually want that. We want just the 1 after it. So we're going to load the palette information into 2006. We're going to clear a carry. We're going to add the base address. Oh, okay. I know why. All right, so kind of mixed two things, but I actually like where I was thinking with this. So what I want to do, this was, I forgot. So param1 is the palette number that we're loading into. I want this to be the palette we are. The palette, well, let's do this. Change this to 4, change it to 0, add param2, load palette. So what I was doing wrong was I, for some reason, assumed that this never got changed, but the parameter we were passing actually was the palette index, so which palette we wanted to load, and then which palette we wanted to load it into, which is not right. So let's see, param2, param1, the palette to load, param2, the palette, and the PPU to load into to load param1 in the PPU into which param1's palette is loaded. All right, so this should be param2 now. And then what I want to do is I want to find the palette similarly. So I want to, let's see, load A, param1. Same thing here, stored into param1. And then what we'll do is we'll actually make y load a param2, no, param1. Well, wait. Increment param2, param1. So we're basically doing the same thing. We're calculating the index, but we're using them for different purposes. So we're going to load A with param1, and we're going to transfer A to Y, and then Y is going to offset the pallet offset, and then we're going to write it into the appropriate pallet in memory, if I did that right. So let's see. I did not. What did I mess up? Let's see. Let's see if the breakpoint helps me identify it. So we're going to load the base address of the pallets into memory, and then we're going to load 4 into param1 and 0 into param2. So we're saying load pallet 4, store it in pallet PPU pallet 0. Right, so same idea. Yeah, same idea here. We multiply the pallet we're storing it into by 4, and we store it and increment it because we don't need to modify the first pallet element. Same thing with parameter 1, because we're indexing into the pallet table on the ROM, and we don't need the first element. So now we're going to write 3F00, and we're going to use the value of param2 as our offset before we write into 2006. And then we're going to load param1 into Y, which is going to serve as our offset into... Oh, okay, so here's where the part of the problem is. This is expecting Y. Let's do this. For X to A, push A. Pull A, transfer A to X. So I want to use X as the counter. Load X 0. And then just say 3. I don't think that fixes the problem. Yeah, I didn't think so. But let's see here. Step into... push A, transfer Y to A. Okay. So load A. Okay, and then we're going to load A with param2, and we're going to do 2 multiplies, and then we're going to do the increment. So it's got 1, and then we're going to load param1, which is 4. We're going to do 2 multiplies, which makes it 16. restore it. We're going to increment it. And then we're going to load 3F into A. We're going to store that into 2006 because we're telling it we're writing into 3F as the high address. And then we're loading A with 0. We're clearing the carry. We're adding param2 to tell it which pallet address we're writing into. So we're going to write that into 2006. Then we're going to load A with param1, which is our offset into the pallet memory. We're going to transfer A to Y because we're going to use that for our lookup. And then we're going to load X with 0. And then we're going to say, okay, so ECB7, is that actually even the right place to be looking for all of this? ECB7. Do we see values that look like pallet values, or do we see values that look like memory addresses? Let's see. You may not be able to tell. ECB7. ECB7. This doesn't look right. If we step out for a second, the memory address that we loaded is ECA6. So ECA6, ECA 0, 1, 2, 3, 4, 5, 6 has in it F. Pallets high, pallets low. Let me see something here. Maps high. So this is loading the low byte. This is loading the high byte. And then we are now accessing the actual data. So is there just a problem with my pallet table? Let me look at the pallet data. So let's see, the pallets has filler tile and then gradient. So what we should see did I do this the wrong way? I mean, it seemed to work, but that's okay. So that's maps, and that's maps high and low, right? Maps level 1, level 2, high bytes, maps, low bytes. Okay, so let me take a look at the actual palette data, I guess. This is that label, and then that's gradient.palette. So if I look at gradient.palette, 1, 3, 4, 5. So do I see that sequence anywhere over here? One, 3, 4, 5. Doesn't look like it. Let's go to the debugger for a second here. Look at this code. So this is saying ECA6. ECA6. But that is... I mean, that's the location of filler tile. Is it not contiguous? Is that why? Like, is pallets... So that's EC26 is low. Is pallets... Let's see, EC26 is low. And then EC2B is high. So that's this. So 0, 1, 2, 3, 4. And then 0, 1, 2, 3, 4. So it's saying it should be am I saying it should be ECAA? Even still, those values are not correct for the pallets. ECAA. Right, that would be over here. Gradient tile. Oh, actually, that might be right for the filler tile. What would that be? That would be EC 1, 0, 1, 2, 3, 4, 5, 6. A6, and then 31. EC31. Oh, it's not contiguous. EC31 is over here. And then EC35 would be following that. What did I say that sequence was? 1, 3, 4, 5. So 1, 3, 4, 5 is over here. So, okay, so the problem is that the palette information is not, is it not stored contiguously? You have A6, it's not. Well, wait, but that would be okay, because I'm looking it up based on this base address, right? I'm loading ECA6. Oh, okay. So the problem is I'm loading... Problem is I'm loading the actual address in and then using that as a pointer. So realistically, I'm actually doing one step too many. What I can do is I can say load palette. And load X param 1. And that's okay. This does modify. We're going to make this say that this modifies address param. We may not keep it with that particular variable. Let's fix that. Let's just make sure that that works though. So the problem with what I was doing was that I was, kind of incorrectly offsetting some stuff here. Load y 0 1. That looks okay. I mean, it should work, and then let's figure out how to make this a little less gross. Oh, come on. What went wrong here? So loading 4 into param 1, I'm loading 0 into param 2, and I'm calling the subroutine. So that's pushing the registers, and then I'm loading X with param 2. Why is param 2? Oh no, I'm loading param 1, sorry. Into X, and then I'm going to set up adder param 1 to point to ECA1. And if we go to the Hex Editor, ECA1 is for what? It's these ECA1. Really? Pallets high. What is X equal to right now? 4? EC 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So ECA1. 1, 2, 3, 4. Okay, that might be right. And so now it's going to loop through. I say it might be right because I don't remember what the color codes are supposed to be. We can 0F 0 1 12 10 12. Yeah, that's actually right. Okay, so we're going to load A. We're going to now load A with we loaded this. Now we loaded the value in 2000 and param 2. We're gonna do the multiply, which doesn't matter here. We're gonna increment the index. We're gonna store the memory into 2006 so that we can offset into the palette we need to write into. Did that again, and then we're loading Y and X with 1, and then we're looking at ECA2, and we're going to write the palette values into 2007, and then we're going to increment. Dummy, you're not incrementing Y, which means you're writing the same value over and over again. I didn't rebuild that. There we go. All right, so the palette's now loading correctly. All right, so is there a way to make this less gross? I mean, I like that we can pass in the parameter for which palette we want now. And I like that I just don't like that we have the double counter here. We'll just do compare Y. right? Because we don't need to do anything with X there. We still need X for the top. Okay. Turn off that breakpoint. Yep, the map's all busted, but that's all right. So now we load the level. This is pallet 0 that we need to, whatever the first pallet is that we need to load. So what we're going to do is we're going to store that into param1. We're going to load 0 into param2, and then we're going to call load pallet, right? And then we're going to increment y, and then we're going to load guess we can make this a loop, right? That's the row count. We increment sprite mem. Load y should still be 0. So we'll call this pallet loop. So we're going to load this, store this, load a, transfer y to a, stored in param2, jump subroutine, compare y to 4, branch if not equal to pallet loop, increment y. So that should load the pallets that are in the map. So let's see if those get loaded correctly. And then we need to modify the attribute table once the actual, that actually looks like it maybe happened properly. And it does look correct. If we toggle through these, they look right. Okay, cool. So the pallets are getting loaded correctly. We're getting the 3 pallets that are used in the map. The problem now is that we need to we need to modify sprite mem now to be offset by the number of, by the 4 pallet counts. So we want to load a 16, clear carry, add carry sprite mem, store a sprite mem, and that'll get us into the actual tile data. Maybe, not really. Just kidding. Did I not assemble this? It's close. What did I do wrong? Let's see. It's just 4. 4 times 4, right? Oh, does y need to be reset? Maybe. The only other possibility is that we're overflowing a when we do the increment, and so add with carry, store a sprite mem, branch carry, clear, skip, sprite mem inc. And this we want to increment sprite mem +1. The reason we need to do that is because the carry was set, which meant that we would be off because sprite mem would have jumped. overflowed from the value it was to back to a lower value. So I don't think that was the problem here. I think we're just offset incorrectly. That's the high value, that's the low value. That's the row count. We increment sprite mem once. We then loop through for 4 pallets. 4 pallet. Oh, wait a minute. We don't want to add 16. We want to add 4. There we go. Well, sort of. That still seems... That's the... It partially loaded it correctly. What happened? Why is it not loading this right now? Load X0, load Y0. Is it still? It's just 4 bytes. And carry sprite mem, store a sprite mem, branch carry clear. Let's take this out for a second here. What is this doing? Why? Oh, right. Okay. I forgot. So it needs to, after it's done with the first screen, it needs to load the attribute, and then it's done. And the only... Okay. So let's see. So this is loading in the tiles based on the meta tiles. Check to see if we're done with one screen. I need to load the attributes. Compare branch not equal to load tiles. Otherwise, it's going to load A, and then it's going to load, let's see, 23C0. 23C0, what is that? Oh, well, that's going to be in PPU memory. Actually, let's take a look at the name table. 23C0. I think that's going to be... Yeah, it looks like it's getting ready to just blank out. Okay, so yeah, so it's basically just getting ready to... it's just blanking out the attributes. What it needs to do is it needs to actually use the attribute information that we've written. So, let's see. That would be sprite mem Y. So let's see, load A tile Y. Transfer A to Y. I'm not exactly sure. Let's see. So X is cleared out here. A is cleared out. What we need to do is we need to say, okay, load A, I believe this would be right, load a sprite mem Y. Let me think about this for a second. If we have two 8x7, that's 56. That will fit into a byte. Okay. I just wanted to make sure we weren't going to overflow Y by trying to load it here. So we're going to load that value instead, and then we're going to increment Y. We're going to pair X Would it be as simple as that? I don't know. I think Y will be... Oh, okay. That was something. Is it using the wrong pallet value? The other thing is the value that it increments the screen mem to, let's see, the tile memory to is technically wrong now because it is not, you know, we should probably put, I was going to say we could put it the attribute stuff before, but that's not really going to help us that much. So tile Y is 38. We want to effectively tell it, no, it's not actually 38, it's 70. Oh, that's 38 hex though. 38 times 2 is 70. And metatile Y is going to be 8. So that it skips. Oh, but that's not... Wait, is that right? Is that the right number of bytes? Yeah, I guess that's the right number of bytes. And then that's screen mem. That's okay. That should be correct. It's actually close. We're still off. Let's see. It's 64 bytes past where we were, but it's effectively a full screen's worth of. Oh no, it's not. Okay, wait a minute. 38 is 56. So it's actually not 38. It's 38 plus. It's 56 plus 64, which is 78. Right, because I doubled the 56, which is the number of tiles in the screen, and the problem is that the attribute bytes is 64 bytes, so that would be why that may be off. But did I do that math right? I don't think I did that math right. Because let's think about this for a second. I'm trying to think. I don't remember. This is a little frustrating because I don't remember what these. I mean, I remember what they are for, right? The tile Y is the inner loop of tiles, and the M tile Y was the meta tile. And I was doing counting, and we were looping through M tile Y. Let me think about this for a second. So, is M tile Y? It is. It's used here. Yeah, it's used here to determine. That's for the meta tiles. Tile Y is being used for the inner tile. I should put some more comments on how this is all working. So that's actually 2 bytes being used in load after load level. Let's see here. Are we modifying y in any way when we come into this? We're not. So this should be right for the attributes. The challenge is getting it ready once we're in the code that's handling the scrolling. I don't remember what the initialization should actually look like here. So that's doing the scrolling, and okay, so it's incrementing the camera Y, and if that's 8, then we're going to the next meta tile sub row. So what we do is we increment the meta tile sub row. So we say store that into camera Y, that's fine. We're decrementing M tile Y for the next meta tile. We're loading that, we're comparing it to FF. And then we're saying, okay, if it's equal, we want to increment the meta tile row, which okay, so we're saying 3 here, and then is it the row mem that is not getting initialized properly? That's screen mem. That's where that's the next row that we're writing into when we hit the scroll point. So it's, I think actually the problem is that maybe row mem is not set up correctly now with these changes. Load new row. Where is this being initialized? So this is being initialized based on maps high and maps low and tile Y. Well, this all made sense when I wrote it. Gotta do a little bit better job here with the comments. See. Just walk through this. So this is our pallet initialization here. So add carry sprite mem to the 4 bytes and then store it, and then if it overflowed we increment sprite mem. We read 2002 and we store the base name table address in here, which is 2000, right? And then we say, okay, we've got tile X and tile Y and M tile Y and M tile X all equal to 0 because we're loading the first screen from the map file. And so let's see, so we get the tile X, and then we divide that. All right, so take the X and divide that by 4 to get our what are we? This is tile X, so this would be sorry, it's been a while since I had looked at this, so I'm kind of reconstructing this now. Again, probably a good reason to have commented it in the first place. All right, so this one, I remember we are deliberately dividing and then multiplying because we want to truncate it to fall on the beginning of a row. So take the Y and divide by 4, then multiply by 8 row width to get beginning of the row. Let me think about this for a second. So 4, and we do once, we get 2, and then we do once. Yes, it's 5 by 4 to get our offset into the map. So now we're saying, okay, now we've got the row. So take the row offset and add the X value to get the actual meta tile. So this would be 2, 4, 6, 8. Why is this not making sense to me right now? So that's actually the map data, which is, let's see. So that's our meta tile value, and then we're going to multiply it by we're shifting it left 4. That gives us 16 times 16. Why is it times 16? Shouldn't it be times 32? Maybe? Store a temp, load tile Y, shift left, clear carry, add temp. Oh, yeah, should have commented this better. I think I remember having the same issue when we were writing it. I was trying to figure out how to do this, and there was something stupid I was doing with the meta tiles. So let's see. So this is our 8 by 7 screen, and we're saying, okay, we are starting off with an x and y at 0, 0, and we're going to increment x until we get to what? What are we comparing x to? To 32, right? So we are taking the x value and dividing it, right? Let me think about that. So we're dividing it by, is this the screen offset or is that the meta tile index? Load a meta tiles X stored in 2007, then increment both of those. And okay, am I, oh, I think I know. I think I remember. This is only a value of 0 to 4, 0 to 3, in order to provide us with the, I do think I remember now, with the index into the meta tile row. This is only a value of 0 to 3 in order to provide us with the index into the meta tile column. All right, so if that's the case, and these are absolute positions, well, that still doesn't make sense. Give me a second to. This was our trick for doing the modulus, right? Because we know that if it's a power of 2, we can just apply a logical and, sorry, a bitwise and to the value, and it'll keep it within that range that we want. So what we're doing was we were saying, okay, so keep that within 0 to 3, and then check this to make sure it's not 32. Oh, wait a minute. Okay. Was that because this is 32 based on the normal 8x8 tiles? That might be why. Skip next row. So when it skips to the next row, it's just going to continue on to load tiles. So let's see. Let's just keep going. So tile X gets incremented to 1, M tile X gets incremented to 1. We try to cap it to 3. Then we load this, check if it's 32. If it's not, we go to the next row. So then here, we're dividing by 4 again. So when we get to 4, it would become 1. And then so why was I doing that? Because, oh, because we were dividing by the number. Okay, I remember now. Because we were dividing by the number of tiles. So it's, okay. So, yeah. So this counts the number of tiles along the row. Counts the number of tiles along the column. 0 through 32, 31 really. So, okay, so that's why, because we were in it, okay. So basically what it was doing was it was saying, okay, I have this value M tile X that I'm incrementing from 0 to 32 essentially as a counter I'm dividing by 4 because I want to know which of the meta tiles along the row it falls onto. Storing that into temp. Take the row offset and add the X value. So yeah, and then Y is divided also by 4, again to offset it based on the number of tiles that are in the meta tile, but then we're multiplying by 8 because we want to actually index into the beginning of the row. So multiply by 8 to get the beginning of the row for the meta tile data, right? So this operation converts the Y value into the number of rows based on the meta number based on the size of the meta tiles, and then we're actually multiplying by 8 to offset it accordingly through, into the array of meta tiles there. So once we have that, we then add this tile X value to it so that we have our lookup for what the meta tile is. Now that meta tile value has to be multiplied by 16 to find the individual tile that we are actually loading into memory. So we're going to store that into temp now. And then we're taking M tile Y. Let's see. Shift left. So we're multiplying that times 4. So that's a meta tile. Storing that into temp. M tile Y. Load A M tile Y. So this is the counter from 0 to 4. We're multiplying that by 4. Let's see. Meta tile X. Right, so that's because we got the meta tile value, and then we got the index into the meta tile array by multiplying by 16, and then we're taking... Oh, right. And then we're looking at, okay, which actual tile within the meta tile is it that we need to load? So get the meta tile value, find the subtile in the meta tile, Y, add in the row offset to get the actual tile. Load A with the tile value, write it to the name table, and then we're incrementing the X values, and we're checking to see if we've rolled over into the next meta tile here, and then if we're also checking to see if we're in the next row. If we're in the next row, then we're going to reset tile X and increment tile Y and M tile Y, and then we're going to check to see if M tile Y, and then we're going to force M tile Y to stay within the 0 to 3 range. Then we're going to check to see if tile Y hit the bottom of the screen, and if it did, then if it didn't, then we're going to continue to load tiles. Otherwise, we're going to... Actually, I think we don't even need to do this because technically it should be at the attribute data already. For that, let's see, that should be right. If we did this right, it should already be at the attribute data. It looks like it is, because it does look like it updated this at least partially correctly. All right, so assuming that it did that right, let's do this. Let's get that breakpoint set so we can just make sure that the location that it's writing to is as expected. Oops, I did not turn that back on. It's not going to work if it's not on. Okay. So let's go take a look at, it was looking to write 23C0. So if we go back to the Hex Editor and go to the PPU memory to 23C0 here, we should see that update as we start writing into memory there. Maybe. Value is 0 for everything, it appears, or so far. Which actually that's fine. Thinking about it, most of the meta tiles are going to use attribute set all to 0 because they're the first palette. The first palette is this palette for the gradient, and then for the background tiles that have no actual content, they would continue to use that palette. So that's okay so far. We step over until we actually get a value. I feel like we should have. What's the value of X right now? It's 16. Wait a minute. That's why we needed to do the increment of y, because otherwise it's just loading the same thing over and over again. Right. That would explain why the ones that aren't the right color aren't the right color. All right. So if we hit start, after a few, we should see the color get updated, or the attribute table get updated. I think it's like going to be in 7. There it is. And then did it update this? It did. Okay, cool. So that's all right. So it where's the PPU viewer? This palette. So it's using that palette. If we go to the asset tool, blue tile. Oh, I forgot I changed this. Well, that explains create meta tile, export project. See, I didn't even realize, I forgot that I had changed the color of that. So that actually means that that worked. Okay. So let's copy all this content back and rebuild it. This, rebuild it. We should get the right color blue that I was expecting that matches what's entiled. Oh, now we're not getting anything. Why? PPU viewer. Because that palette is not correct. Did I not copy all the files? Or was there some sort of, is there some sort of bug with the export here? Let's see. Copy all of that to here, replace. Okay, and then rebuild this. That's weird. It was working. Or did, you know, I didn't. I assumed blue tile got converted over correctly. It didn't. Damn it. That's my fault. All right. That's what happens when you don't check things and you just assume that they work the way they're supposed to. Or the way that you imagine, instead of actually verifying that. All right, so that was the problem with the blue tile, was that the palette had the back, I mean, it was working, but it was not working the way I wanted it to. The blue tile background color was the color that was used for the actual tile itself, so it was not getting set to a visible color when we actually loaded it into the PPU. So now we should get the right color result. The only question is going to be why. Yeah, there we go. So now the only question is why we're not getting these tiles loading dynamically correctly when we scroll. And again, it has something to do with this. So let's see. So tile Y is set to 38, which that's 56, I think, in decimal is what I said before. So 56 in decimals, 38 in hex. So that's the number of tiles that we, it's the number of meta tiles that we loaded. And the problem is going to be that we then are loading 64. Oh, it's 64 bytes. It's not. Okay, hold on a second. So let me think about this. So this is loading from maps low. This is okay. So the problem is that it is using, okay. Problem is that this is the number of meta tiles, but then there's 64 bytes after that. Well, so that would be 64 meta tiles though, because each meta tile is 64 plus 56, 58, 56 plus 64. So 120 should be 7, 8. Because we want to skip the attribute memory, or attribute data that we stored there. Okay, it's close, but it's still not 100% right. How much is it off by? Looks like it's loading it off by 3 meta tiles. Is there additional data that I'm writing that I forgot that we added? So that's the 64 bytes there's the 4 bytes for the pallet. So there's the 4 bytes for the pallet, there's the screen, there's the 64 bytes for the attribute data, and then the rest of the screen is written, or the rest of the map is written. And in this, we're adding 78. We're saying 78 is the tile Y, but I guess the problem, let me think about that. So it was 38. When it goes to use tile Y again, well, it's actually using M tile Y. And it's because it's decrementing that M tile Y. And it's using that because why? Because it assumes M tile Y is set to 4, which should, yeah, that would be right. Well, let me think about this. Is it because it's what did I say it's off by? It's off by 3. Can I just kludge this and say something stupid like just say 80, put 81 in here, and that will offset it without really understanding why? That's in the wrong direction. So 78, 75, without really understanding why it's off by whatever it's off by. That's still too. So now it skipped. It looks like it skipped a row, but it's actually otherwise okay. That attribute is not right, but we can fix that. That's not a big deal. The rest of it is okay. That's not half bad. So the question is, why does it not load that one row? Or does it load the row and we don't see it because of, no, so there's no gap. There's not supposed to be a gap here. So it's missing a whole meta tile row. When it was 38, it worked. Let's see. Store, load A3 stored in there. Add tile Y. Increment tile Y1. Load A8, clear carry. Add carry tile Y. So it's adding to the next, right, it's incrementing that to the next row. Oh, wait a minute. 74. I think I know what happened. Hold on. 74 minus 8. 66. Wait, that's in 4 minus 8. That's 6C. Okay. I went in the wrong direction. Plus 8, 7C. Oh, right, because it's adding 16, so could have done that in my head, I guess. Okay. So 7C, that's 124. 124 minus 56. Oh, now I'm back in. 24 minus 56. Minus 56. 68. Why are there 4? Oh, maybe because of the pallet bytes? Yeah, if it's not... Yeah, it's not okay. All right, so that makes sense. So this is 60. So it's 56 plus 64 plus 4. So okay, so let me write this down. So this is the number of meta tiles in a single screen plus the attribute bytes, 64, plus the 4 pallet bytes initially included. So that has to be offset that way in order to make that load properly, and that's fine. Now the only thing that's wrong here is this one last attribute value. Why is that? Am I just messing up my loop and it's not initializing the last byte properly? So let's see. This is 1632. This is our 64. What part of the name table is that? It's close to the bottom. That's going to be 2385. Well, that's the tile 2385. Or the address 2385, I should say. That's 28 times 32 times 28 plus 4 is 900. Divided by 4. And then divided by 4 again. 56. So 23Z0 plus 38 hex. 23C0 plus that. 23F8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's this byte, is that right? So I just didn't initialize that properly. Let's see. 40, that should be 64 bytes. It is 64 bytes, isn't it? Because it's the 1024 by 9 minus 960, and that's only 64 bytes left. 64 byte array. Is there a bogus value in the map data? Let's take a look at it in the Hex Editor. So our first value is the rows. This is our palette. And then we have 56 bytes of screen. So that's only 43 bytes. Here's 50, that's our screen. And then 64 bytes of attribute data. Here's our 64 bytes of attribute data. That looks right. Maybe I shouldn't be commenting this out. Maybe there was a reason I did this. Let's see if I force the attribute right into the appropriate offset. Yeah, it's still not loading it right. 23C0. Let's do this. Let's make sure 3C0. That's 960. That's right because it's 32 times 30. Oops. Right? 32 times 30. That's 960. So 23C0. And then sprite mem It's possible that it's just y is not the right value. I guess that's possible. Let's see. Yeah, that would make sense because it's not. Let's do this. So load y. That should be. Y should be the offset of, let's see, did we increment sprite mem here? We did, I think, for the pallet loop. We incremented it by 4 so that it's offset. So then we should just increment it by, what is that? That was 38 hex. So offset Y by the number of meta tiles, and then that would give us the attribute data cleanly, and it did. All right. When we load that works. That loaded the. Okay, so that was what the problem was, that it was the Y value wasn't actually at the end of the meta tile data. And that makes sense because we were using it to index into whatever the meta tile data was, or the actual individual tile data for the meta tile when we were doing this calculation here. And so just using Y here wasn't clean. We had to offset by the size of the screen. So in the file we have this, we have the row. Oops, that's weird. We have the row height, or I shouldn't say height, it's really a row count. And then we have our pallet initialization, right? These are the meta tiles. And then we have our 64-byte attribute data. So we just offset by the number of meta tiles, and we load this into the attribute table, and that's it. That worked. So now, if we let this scroll all the way, I think it should show the green tiles at the end properly too, assuming that those got loaded by the asset tool properly. Well, that's still not 100% right. That's weird. Gotta look at why that got messed up. Let's see if those green tiles have the right value. Come on, there it is. And they don't have the right color, and I don't. Let's verify in the asset tool that we actually have them correct right now. So green tile should be, if we look, I mean the colors there are not right, but they're at least registering as a different type of meta tile. Tools, PPU viewer, that would be, oh right, no, okay, yeah, sorry, I'm expecting this to work for reasons that are mostly due to, I think, just being tired. Okay, so the reason that this isn't green is because the attribute table hasn't been set up to use this palette. It's been set up to use this palette and the blue palette, that blue palette there, because that's what was in the first screen. If we go to the map, where are you? If we go to the map, right? It's just these and these blue guys, right? So that's why that's not working, because this is trying to use the same palette as the blue tiles. If we go to the Hex Editor and we go to 23C0 and we change, let's say, where would that, if we change like this one and we make it is that? That's palette 1. So 010155. I'm not sure I'm modifying the right one, so yeah, that wasn't it. Nope. Nope. There we go. So once we get the attributes updating properly, what you'll see is you'll actually see the proper colors in the attribute table. Palettes being changed in the attribute table to make this reflect the actual colors of the map for the green tile. So that's why that didn't do what it was supposed to do. But it's actually at least loading the attributes properly, it seems, for the first screen. What we can do just to verify that real quick, and then I'm going to wrap the stream, is I will put gradient tiles here and fill these and fill those and save, and let's export that and go back to this and just make sure this reloaded. No, it didn't. Where did it export it to? Oh, it didn't export it to anything at all. It was asking me where I wanted it to be. Okay. Replace that. Yes. Okay, cool. So let's export that. And then we have this stuff. And we just reload this. Okay. And so you can see that this looks correct. I don't see anything in the name table that looks like the palette didn't get loaded properly. So I'm reasonably certain that, yeah, so that's interesting. Oh, I wonder if we're having some sort of issue with the attribute table getting corrupted, because it seems like it's changing. Oh, no. I know what it is. Okay, I know what it is. It's because we're updating. Okay. It's because we're updating the row with the gradient tiles where there were previously these solid blue tiles. So if you look at the palette, you have just this gray and black color. So that's why it looks like it's corrupted, but it's actually okay. It's just we're not, same thing with as with the green. It's just that we're not modifying the attribute table, so some of them are going to look wrong. So that's good. Okay, we made a decent amount of progress here. The next step will be as we are flying through and loading these tiles, we need to now update the attribute tables accordingly where they need to change for each row that we load in. So that's what we'll do in the next stream. Sorry that we took a while here to re-understand what the loading subroutine did, but I had forgotten. It's been several weeks now, I guess, and it wasn't exactly commented at all, and we had to add some code there for the palette loading. So anyway, it was good to revisit it and make sure it was working okay and get it going. As always, if you have any questions, feel free to message me on Twitter or comment on YouTube. Also on Nintendo Age in the forums and the Discord, and And yeah, I'll see you Thursday, same time, 9 p.m. Eastern. Hopefully you guys are enjoying this series. Seems like people are interested in it, and keep an eye out. I'm really hoping this week to do the shorter videos, get 1 or 2 of those done, again, to kind of condense down the stuff that we've been covering here and make it a little bit more manageable, so that you're not watching 1, 2, 3 hour videos. So again, thanks for watching. See you Thursday. Have a good night.